You look at the old steam boiler. They still make these things, you smile. You think you can just yank it out, slide the same size replacement in, couple days, you're done. Don't fall for it, detective. That's low bid Pete thinking. You're better than that. I'm Ray Wohlfarth, and this is Boiler Room Detective Channel. This video will cover the common mistakes I've seen on steam boiler replacement projects. My 14 boiler books are available at T.F. Campbell, Pronto Heating Supplies, Amazon, and heatinghelp.com. First mistake, treating the steam boiler like a hydronic one. Designers and installers who try using their hydronic knowledge for steam will find that approach backfire over and over. Steam is completely different from hot water. What works in a hydronic system will absolutely destroy a steam system. It's best to view a steam system holistically. In other words, the entire system from the boiler to the last radiator in the building. Every component matters and could affect how the system operates. Ignoring parts of the steam system could cause short cycling, uneven heating, noise or water hammer, flooding, premature failure, high fuel bills, or safety issues. Number 2, incorrect boiler sizing. When a replacement hydronic boiler is sized by performing a heat loss on the building, steam systems are sized on the connected load, or the EDR, which is the equivalent direct radiation of the connected radiators. You can also use the boiler's gross output rating and compare it to the connected EDR. The connected load includes all heat emitters, like radiators, baseboard radiation, and steam coils. When we get that number, we add 15 to 20% more for the piping. This is for when the system starts cold. The cooled pipes will heat all the steam before it even reaches the radiators. Once the pipes are heated, steam can enter the radiators. You can find forms for collecting the heat emitter sizes on sites like heatinghelp.com. If the boiler's undersized, air removal suffers, the system runs longer. If it's oversized, you'll have short cycling increases, fuel consumption rises, and steam quality may decrease. Problem number 3, not following the manufacturer's near boiler piping diagram. I have a principle I use when looking at a replacement steam boiler, and it never let me down. Always assume the old boiler is installed wrong. In most cases, they are, and it really affects the way the system operates. The job of the near boiler piping is to wring out as much water from the steam as possible and reduce carryover. It does this by slowing the steam velocity to 40 feet per second and lower. The slower the steam, the less carryover. Some of the common near boiler piping errors are: the header is too low or undersized. Steam piping is not pitched. Missing or undersized equalizer pipe. Wrong takeoff location. Using copper instead of threaded steel pipe. No swing joint. No Hartford loop. Swing joints allow for expansion to prevent stress on the boiler sections. When the near boiler piping is wrong, the system may experience wet steam, priming, surging, water hammer, uneven heat, and possibly a voided warranty. The reason we don't like using copper is that it expands 50% more than black iron, which could cause leaks. Always follow the manufacturer's recommendations for near boiler piping, even if the old one looked different. Pipe insulation is critical for steam systems. An uninsulated steam pipe loses 80% more heat than an insulated one, making the basement a sauna. The heat is annoying and wasteful, but that's not the real issue. When the pipe loses that excess heat, the steam condenses faster. This overloads the steam traps and causes banging pipes, steam stall, boiler going into a vacuum, air vents panting, and uneven heat. Number 4, ignoring the rest of the existing system. As I said earlier, steam systems must be evaluated holistically. For example, a plugged air vent at the end of the piping could stop steam from getting there. A sagging condensate pipe could stop heat altogether. Evaluate the entire system before giving a bid for replacing the boiler because you will own every new issue that pops up. This includes steam traps, radiator vents, or wet returns. And by the way, they're often plugged or restricted near the boiler. Number 5, improper startup. Wrong pressure settings. Keep the pressure low, 2 psi or less, not skimming or cleaning the boiler properly at startup. Ignore combustion setup, venting, or system compatibility. Check pH and treat water properly. Verify low water cutoffs and pressure controls work before firing. Number 6, ignoring main venting. Without proper air venting, air can't leave, radiators heat unevenly, fuel usage rises, and occupants complain. I like to replace the main vents in the system when changing the boiler. Also make sure the air vent is properly installed. It should be 15 inches or more from the end of the steam main and 6 to 10 inches above the steam pipe. If you're installing or replacing a steam boiler, avoid these mistakes and you'll have happy customers and equipment that lasts. Drop your biggest boiler room horror stories in the comment. I read every one. Like, subscribe, and hit the bell. Thanks for watching. This is Ray Wohlfarth, Boiler Room Detective, and I will see you on the next case.